Assalamualaikum. My name is Muhammad Ali Amsyar bin Ahmad. My entry number is SB18117. So my point is case study. Our group decide to do the problem group assignment for the tutorial 2, the question 3. This is an example the question. So the application in the real life is the shaping machine. So the shaping machine is the quite different frame mechanism. So the shaping machine is used to machine the flat metal surface, especially where a large amount of the metal has to be removed. The motion of the mechanism inside the shaping machine can be seen in this diagram. So as the disc rotates, the top of the machine moves forward and backward, pushing a cutting tool. The cutting tool removes the metal from wood which is carefully bolted down. So for the proof the mechanism, we use the application Gym software to do the simulation and find the calculation, velocity, angular velocity, acceleration and angular acceleration. So we can see the outcome result by look the graph. So this is an example how we run the program simulation. Alright. So that's all for me about the point case study. Thank you very much.
The shaper is a reciprocating type of machine tool intended primarily to produce flat surfaces. In a shaper machine, the rotary motion of the drive is converted into reciprocating motion of a ram holding the tool by means of mechanism inside the column of a machine. In a shaper, the metal is removed during forward cutting stroke, while in return stroke no metal is removed. Therefore, in order to reduce total machining time, the shaper mechanism should be designed. Can we design a shaper mechanism that can perform a quick return motion? Does the forward stroke angle and return stroke angle affect the return motion?
Assalamualaikum and good morning to Prof. Mazlan. My name is Muhammad Shafwan Akid bin Muhammad Akin. So I will continue our group presentation. So my part is analysis part. So overall, I will this analysis part will cover for the gym simulation. So I will compare the result between gym simulation and the manual calculation. Okay, let me study. Okay, first I will show you about the gym simulation. Okay, this result for the velocity. So this is point A, point B, and point C. So the velocity at point B is 1.2 meter per second, and we get the VC and angular at point A to B, and angular point element B to C. Okay, this is the result that I get from the gym simulation for the acceleration. So we get here about acceleration at point B. It is translating about x and y axis, and we get the acceleration at point C, and the angular acceleration at the point B to C here. It is 130.56 that per second square. Okay, this is manual calculation. So I calculate about the velocity at point C and I get answer for the angular velocity at point B to C. Okay, this is the equation. So the formula is VC equal to VB plus VC. And we take the component J to get the angular BC, and for the component I, we get the answer for velocity for point C. Okay, this we get the answer for the velocity at point B, where the result we get from the magnitude with component ij. So VB is 1.1993 m per second. Okay, this is about the acceleration. The equation is angular acceleration at point AB times with relative position at point B to A minus angular squared with the relative position, and from the magnitude we got the answer. It is negative 4.8 m per s squared. After that, we calculate for the angular acceleration at point BC and acceleration at point C. So from component J, we get the answer for angular acceleration at point B to C, and for component I, we get the answer for acceleration at point C. Okay, this is the result from the simulated simulation and the manual calculation. So from our result, we get the velocity at point B, we get the velocity at point C, angular acceleration BC and AB, and the acceleration at point B and point C. Lastly, angular acceleration at element A to B. So we observe that there is a quite little difference between simulated value and manual calculation. So the different value also affected by number from decimal place that we use. Okay, that's all from me. So I will pass to the next presenter. Okay, thank you.
Hi, my name is Chazen Ho, FB18006. First of all, we using the GIM software, we design the drawing as shown with 3 points, which is A, B, and C. AB with a length of 300 mm, BC with a length of 125 mm, both 45-degree angle with the horizontal place. Then we go to the simulation part. First of all, we set the angular velocity for AB to 4 with no acceleration. Then, okay, we have set it. Then we can straight away get the result that we want. Like velocity over C is 1.697056 meter per second, and for example for point B we get a 1.2 meter per second. Then here is the motion of the simulation. Then we only focus on the first point because we purposely set it in the drawing as the first point as 45 degree with the horizontal. Hence, we can directly get the result we want in the first point. For example, we go to the angular acceleration for here. This is a very small amount with almost to zero. Then the angular velocity, angular acceleration for BC, we get around 130.56 radius per second squared. Uh, so as I say, we only focus on the first point, hence we can directly take the result from the first one as what we want. Okay, that's all for me. Thank you.
So for the conclusion, the gym application is very useful to do the simulation and very helpful for the find the simulation and mechanism movement, and velocity and acceleration can be obtained and depicted as the motion is performed. Also, graph and table with this data can be plotted. Every kinetic construction can be demonstrated. Instantaneous tensor of rotation, speed, and moving polarities, acceleration pole, acceleration circle, and so on. So, also the conclusion and the outcome result will be the very accurate by the using the simulate. You can this is the example result can combine with the manual calculation with the simulate value, very accurate and quite same quite same. So for me, the gym software very helpful and useful. Thank you very much.